Right, hi everybody. So today what I need you guys to do is to go into Schoology in your notes and classwork section, and you're going to see notes in there that say rational numbers, and I want you to move that over to Notability, and they're going to match what you're seeing up on the screen right now that says rational numbers with this background. And today in class, we're just going to kind of go over what these are. And then when we're back together on Tuesday, we'll start to work with this through some examples and practice problems. Okay, so opening up the notes in Schoology, sliding them over to Notability. And you can kind of have a split screen going on so you can see the presentation as well as here, and then add anything into Notability as we go through the slides. So first and foremost, we want to know what a rational number is. So we've done a lot of work with equations and inequalities, and now the next step is to start dealing with some of our more troublesome numbers. So a rational number is any number that can be written in the form a over b, which basically just means any number that can be written as a fraction. And there's lots of numbers in our number system that can be written as fractions. So whole numbers can be written as fractions because we can put them over 1. Obviously, any of the normal fractions you're used to seeing, 1/2, 3/4, 2/3, 1 and 2/3, those are all considered rational numbers. What's stated here is that when we're writing them as fractions, the a and the b are integers, so they can be positive and negative numbers, but the b, that bottom, the denominator, cannot be equal to 0. Okay, so our denominator has to also be an integer of positive or negative. So what you're seeing are some examples: 5/6, negative and 1/3, 2.4. The regular number 4, our regular integer, can be written as 4 over 1. So that's why we know it's considered a rational number, because it can be written as a fraction. Negative 1 and 1/3, if I wanted to change that up and make it negative 4/3 as an improper fraction, okay, it kind of fits into the format that it can be written as a over b, because I can transform mixed numbers to improper. Okay, so this form is very important, written as just a regular fraction. A over b, doesn't matter positive, negative, doesn't matter if the a is bigger than the b, but the b cannot be 0. Other forms of rational numbers, okay? So we talked about integers, positive, negative, zeros. They're going to include whole numbers. Any positive or negative fractions. And then any positive and negative decimals that are terminating and repeating. Okay, so what that means. A terminating decimal means it ends. Okay, so something like 0.25. Repeating decimals. 0.333. Okay, so that repeating decimal considers a rational number because 0.333 repeating is actually just 1/3. Okay, it's a fraction that we know. Okay, so as long as my decimal ends, it terminates, because usually those can be written as fractions. And any repeating decimal, because that can be written as a fraction, are considered rational numbers. And then all our normal numbers, okay, -2, -3, 16, along that nature. Besides rational numbers, there's also something called irrational numbers. So those are numbers that don't really make too much sense to us. So they would be non-terminating, non-repeating decimals. Okay, so decimals that don't end, decimals that don't repeat. A big example there is pi. Okay, so that's our symbol for pi. As a number, We know it as 3.14, and it goes on forever, but there's no pattern to that decimal. So that's kind of irrational for us. And then beginning of the year, we talked about square roots, and we just worked with perfect square roots. So square root of 16, square root of 36, along those lines. Those are rational, but we can have square roots of non-perfect squares, like radical 2, radical 13. Because they don't fit under that perfect square root, they're considered irrational. Some examples of rational and real versus our irrational numbers. Okay, so our real number system is something that's used every day. So it's every number that you can imagine falls into this category of real numbers. And then it has some subcategories. So we can break up real numbers to rational and irrational. Okay, so real numbers is like the big thing. And then I can break it apart to two categories, rational and irrational. Irrational doesn't go any further. So there's pi, there's radical 2, there's radical 72, there's radical 8 over 23. Those are irrational numbers. They don't make any sense to us. But rational numbers, 3/5, 1.375, 21.6, 3.56 repeating, that red bubble there, those are all rational. But rational could be broken down to integers, -3, 22, -56, and integers can be broken down to whole numbers. Okay, so remember, integers start to include our negatives. Whole numbers are just 0 and up as positive numbers. So those types of numbers could fall into more than one category. And if you kind of follow the bubbles on your screen, the whole number bubble's the tiniest, but that's incorporated into integers, the purple bubble, which is a little bit bigger. And both of those are incorporated into rational, which is that red bubble. Okay, so all those little subcategories. And again, irrational is kind of on an island by itself. Okay, they don't break down into anything else other than just irrational. So reminders, okay, any expression, a fraction with a 0 in the denominator is considered to be undefined. Because if you think about it, a fraction's division. And if I had to divide something up, I can't divide it into 0 parts. Okay, so if I see something like 7 over 0, I'm going to consider that undefined. It doesn't fit in any of the categories. But if I had the reverse, 0 over 5, that I can do. Okay, because I'm dividing by 5 in my denominator. So with 0 in the numerator, my answer is 0. Okay, 0 in the denominator, undefined. All right, so last piece for today, going to identify each as rational or irrational. Okay, so first one we have is a -2.6. So right next to it, you're going to either write rational or irrational. And that one's going to be rational because it is a terminating number. 0 is also rational. 1/2, also rational. 0.33 with that line over it means it's 0.33 repeating. That's rational. Radical 27 or square root of 27 is irrational. It's not a perfect square. -15 over 3 is rational. 7 is rational. And pi, irrational. So what you're going to see is there are a lot more numbers that we work with that are rational versus irrational. Okay, so when you're kind of starting to identify, that could be something that we do. Okay, is identifying what types of numbers these are. Okay, so that would be something like this slide. Okay, we might work into, as we go through, some order of operations with our rational expressions. Okay, so just kind of things to keep in mind. Okay, so just make sure you have all this on your notes. We're not going to do any homework for the weekend. Enjoy your long weekend. And then on Tuesday, we'll start to put this into some algebraic expressions, and we'll go over the inequality worksheet that I left for you yesterday. Okay, have a great afternoon and enjoy your weekend.